not too bad, but there's a lot going on in the question. I don't know if you've ever done anything like this before, or I don't even know if you recognise the name. Partial fractions. Yeah, see, it's one of these things that you only really do it in a more advanced class. Have you seen this before? You don't think so? Yeah. Okay, so just to start, a little bit of a background. Suppose you had something like this. 2 over x plus 1 plus 3 over x plus 2. Let's write it as one fraction. So the trick is, I'm sure, well no, I didn't have you in semester 1, so I don't know how you do it, but I multiply the bottoms and then I make a cross. So 2 times x plus 2 plus 3 times x plus 1. Have you seen them added this way before?
Yes.
Yeah, great. So on the bottom you would get x squared plus 3x plus 2, and the top you get 2x plus 4 plus 3x plus 3. So you would finish with 7x, you would not, 5x plus 7 over x squared plus 3x plus 2. Yeah. Now what we want to try and learn today is how can I go from here back to this form. So of course, going from here to here is much easier than going backwards. Going backwards is quite difficult, but it's quite useful. This form is more convenient than this form. So I will give you some basic rules I made up to help in the process. So firstly, we're going to look at what's called proper partial fractions. So on the top you have an equation, an expression, and on the bottom you have an expression as well. So for example, maybe you have cubic, and on the top you would have a quadratic maybe. But what's really important for this lesson is that they're proper. That means that the top is lower than the power on the bottom. So for example, you could have a linear over a quadratic, or you could have a linear over a cubic, or you could have a quadratic over a cubic. But what we can't have is like a quadratic over a linear. Okay, so firstly, proper means the top is a lower power than the bottom. Okay, so we're good with that? Yeah. Okay. So, some basic rules. Usually, what happens is you can factorize the bottom. So for example, if it's a quadratic, how many factors? 2. And it's the cubic, it's 3 factors. So I'll just write here B1, B2, and B3, etc. These are the factors at the bottom. And on the top, T1, T2, T3. And what we want to know is what is the T1, the T2, and the T3. Because if you think about it, it's easy to get the bottom, because I said the bottom is just going to be the factors here. What's hard to get is the top. But some guidelines, the top, its power should be lower than the bottom, because if you look back here at my example I did, this here is linear, and here this is quadratic, and when you go back to this, it's still, the top is lower than the bottom. This is a constant, and this is linear. You see that the top is lower than the bottom. So this is kind of the basic idea. There are other principles as well because you might say, well, what do you do if, for example, the cubic doesn't have 3 factors? Maybe it only has 2 factors, you know. So we'll look at different examples, and then I'll show you what to do in different situations. But the first example is just a constant over a quadratic. So this is our first one. So our first example, minus 12 over 3x squared plus 8x plus 4. Yes? Step 1, going to factorize, and I'll be lazy. Mode 53. 3, 8, 4. 3x plus 2 and plus 2. Okay, so not too bad. We're actually, if you think about it, half finished. We just need to find the tops. So, if this is linear, then what is one lower than linear? Constant. So there should be a number here and a number here. Yeah? We have 2 ways to find these numbers. I'll show you both ways, and you just use whichever you prefer in the exam. Well, there's actually 3 ways, but I'm only going to show you 2. Okay, so the first way, what you do is you multiply. Well, let me just write it again here. You multiply everything by 3x plus 2, 3x plus 2, and 3x plus 2. So what happens here? They're cancelled. Then, you could probably guess, you multiply everything by x plus 2, x plus 2, x plus 2. So what happens here? You cancel. What happens here though? Cancel. All of this cancels with all of this because these are the factors of this. So you actually end up with minus 12 equals a x plus 2 plus b 3x plus 2. Yeah. In the other method, the first step is the same as well anyways. So you end up with minus 12 again here. What's different between the methods is what you do next. So in this method, what I'll do is I'll expand, and well, I suppose you actually expand in both methods. Ax plus 2a plus 3bx plus 2b, and then here you group the x's together, so that's a plus 3b x, and then the constant at the back, 2a plus 2b. So you just group them together. And then this method you compare. So if you look at the right, you have x. Do you have an x on the left? No. So a plus 3b must be 0, because there's an x on the right, but there isn't an x on the left. Do you have a number on the left? Yes. And do you have a number on the right? Yeah. So you must have 2a plus 2b equals minus 12. Now, can you find A and B here? Yeah. You remember this in semester 1? It's simultaneous. Two equations, yeah? Yeah. So I'll just get the calculator to do it here. Mode 51. 1, 3, 0, 2, 2, and minus 12. Minus 9 and 3. That's one way to do it. Another way to do it, kind of an interesting way here, is technically speaking, this is called not an equation, an identity. Because I'll give you an example of the difference. Here, this is an equation. If I said here x plus 1 equals 0, what's x? Minus 1. That's an equation. If I said x plus x equals 2x, that's not an equation. You can't find the x here. It's an identity. It's a fact. 1x plus 1x makes 2x. But you cannot tell me what the x is here. Do you understand the difference?
Yeah.
So here, or if I actually, let me put it to you this way. If I said x plus x equals ax, what's the a here? 3. These are actually identities, and often the way we show something as an identity in maths is we put in 3 symbols here. Line, line, line. This makes identity. What you can do here is you can choose any x, and it should still be true. For example, if you let x equal minus 2, this should still be true. Because if I go back here, if I say x is 4, then you have 4 plus 4 plus 4. Does that equal 3 times 4? It does. You know. So, because it's an identity, you can choose any value for x. So I choose x equals minus 2. Now, why do you think I chose that? Cancel this part out. So I get minus 12 equals b times minus 6 plus 2, which is minus 4. Minus 12 divided by minus 4? 3. It's the same answer. And likewise, what could I choose for x next? It's a bit messy, but I should choose minus 2 over 3.
Yeah, okay.
It'll make that part 0. And no shock and surprise here that when you put that in and cancel that, essentially it's like it's like you imagine they were factors or something. Yeah. So then you get your A and your B. 3 and minus 9. So if you go back up to the top here, you've worked out that this one here is a 3 and this one here is a minus 9 then. And now you've simplified it into something more useful. Why this is more useful, you'll see in a lesson shortly. But this is both methods. Now there actually is a third method. But the reason I don't show you the third method is because for the more difficult problems you can't use this method. So I don't bother. Before you write it down, I don't really like this method. I wonder if anybody can maybe have a guess at why I don't like this method. Because you do something in this method that you really aren't supposed to do, but it's okay because it works, but you're not really supposed to do it. Can anyone see what that is? No, that's actually okay. It is something to do with the choice of x, but not that you can choose any value. What I don't like about this method is here, I don't like this step, x equals minus 2, because at the very beginning you're supposed to say x does not equal minus 2 and x does not equal minus 2 over 3, because then you're divided by 0. So when you do this method, you're kind of blind to that and pretend it doesn't exist, which I don't really like. But what I do like is it's much quicker than this method. So what you're going to do? Yeah. Yes. Continue. Okay. Let's continue. So which one do I want to do next? So let's do something like if you look at B here, please. B is done the same way as A. Step one, you factorize, and you get the two factors, and it's going to be the same deal. It's A over the first factor and B over the second factor. But I want to do C with you because C, something interesting happens when you try to factorize it. So we'll just we'll skip B, since it's not too different to A. You'll manage it, and you have minus 6x plus 22 over x squared minus 10x plus 25. Now, when you factorize this here, you get two factors, x minus 5 and x minus 5. Now, this is actually a problem because if you try to write it as x plus 5 here and x plus 5 here, and this is an A and this is a B, watch what happens here. Here you would get A plus B over x plus 5. But A plus B is also a number, isn't it? Like if A is a number and B is a number, then I could have just said C over x plus 5. And there's no way I can get a C that makes this the same as this. So it's wrong to write x plus 5 and x plus 5 here. It must be something else. So what you do when you have what's called a repeated root, you write the root again, but this time you square it. This is the way you deal with a repeated root. Oh, sorry, I wrote pluses, didn't I? Thank you. X minus 5, x minus 5. So you repeat it then. So you repeat it by the next time it appears, you have to square. And I suppose, although I've never seen it happen in the exam, if it was a cubic of 3 of the same root, then I think you would repeat it again, but with a cubed. Okay? So you repeat like this. Alright, and wait. Next, what do I put on the top here? A. And what do I put on the top here?
B.
No.
Yes.
Nearly. No.
Yes.
Yes. What type of equation is this? If you think about it, if you expand it. It's a quadratic, so what should be on the top? Not a linear. So actually you have bx plus c. Yeah, you get the idea? Okay. So how about we just use the easier method where we multiply everything by x minus 5, 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 x minus 5. So what happens here? That cancels that. One of these cancels one of these, and both of them cancel that. So you end up now with minus 6x plus 22 equals a x minus 5 plus bx plus c. Okay, what value should we choose for x first? 5, yeah. So this would be, if I choose x equals 5, this one would be minus 30 plus 22, that's 8, isn't it? Thank you. And this is gone. And this is 5b plus c. So it didn't quite help us here. But we could choose something else for x. What could we choose next? Maybe we could choose x equals 0. That could make it simpler, maybe. What would you get then? You'd get 22 equals minus 5a plus c. So this method isn't really working, is it? It's not giving us nice values. So we have to use the other method. So we have to simplify a little bit here. ax minus 5a plus bx plus c. So on the left I have minus 6x plus 22. And on the right, how many x have I got? A plus b. Isn't it? Ax and the bx here. X. And then plus c minus 5a. And you realise, oh rats, this is a problem as well, because how many equations can you make? You can only make 2 equations. C minus 5a equals 22. You can only make 2 equations. So this method doesn't work. So what we could do is you could actually do some kind of use of both methods. So you could do something sneaky, like you could say, let x equal 5, x equals 0, x equals 1. How many equations could you make here? 3. So you would get, what did I say, minus 8 equals 5b plus c. And then you could say 22 equals minus 5a plus c. And then if I put in 1, I could get 16 equals minus 4a plus b plus c. And then you have 3 equations. You could minus these to make an AB equation, and you could minus these to make another AB equation. All these feel too long. There's actually something else you can do. If you did do it this way, you would get the same answer. But there's a very, very nice trick that I want to show you. But I wanted to show you that if you try to continue, your life is going to be difficult here. So here's the trick. If I rewind it a bit. Oh, I can't. Alright, I'll just write again. Why do I write a on the top here? Because this is linear and a constant is before linear. And why do I write bx plus c on the top here? It's linear. But there is another rule here, a very, very useful rule. And it says that the number of constants on the top should be less than the number of constants on the bottom. So for example, here we have 2 coefficients, 2 constants. You have 1x minus 5. So how many constants should you have on the top then? You should have 1 less. So that's a. Here, how many constants do you have on the bottom? Again, you only have 2. A 1 and a minus 5. So how many should you have on the top? You should only have 1. And we have 2. And the great news for you is you are allowed to make one of them 0 because you should only have 1. And you might be thinking, oh, but if I can choose, wouldn't I get 2 different answers? You do get 2 different answers, but both answers simplify back to this, which is useful to know. So, which one will we choose to make 0 here, the B or the C?
C.
I would choose the B. Yeah, to get rid of the X, so it's only a C here. And now you can proceed like it was originally. Okay? I don't know if you need me to continue now because it's going to be the same as the last example and we could go on to a different type, or... Well, we'll do it quickly. Let's try and do it quick. Minus 6x plus 22. So if you multiply by the factors, like last time, yeah, equals a x minus 5 plus c. That's it, nice. Much nicer. So first we make x equals 5. Here, what do we say this one was? Minus 8 equals c. And then next, it doesn't actually matter what we use next. We could use like x equals 0, because then you get 22 equals minus 5a plus c, and we know c. Yeah, so then a would be minus 6 when you solve it. So we have two answers here.
And then I don't have to be right.
Huh?
Do I have to be?
No, the b is 0.
Oh, just
You
put
can,
it be 0 and
yeah, you're allowed to do this because the top needs to be a power lower than the bottom, and also the number of constants on the top needs to be one lower than the number at the bottom as well. Yeah. Now, that's the a and that's the c. So you've written this as minus 6 over x minus 5 plus, well actually minus as well, minus 8 over x minus 5 squared. If you add these together, you do get this. Okay, so maybe you want to write this one down. But really what you've learned that's important here is the trick with the constants. We have some more examples to do. Got that? Okay. Yes? If you're wondering what you would get if I wrote bx here, let's just change it to bx. So if this was bx instead of c, this would be bx So when I make x equal to 5, then this instead would be 5b. So then you would get b equals minus 8 over 5 instead. And then next, when I put x as 0, it actually doesn't change because this piece is gone. Oh no, it does change. This piece is gone. You get minus 5a equals to 22. So then a will be minus 22 over 5. So actually the second answer here could have been minus 22 over 5 over x minus 5 minus 8 over 5x over x minus 5 squared. And believe it or not, these two simplify to this, even though they look quite different. They still simplify, which I think is very interesting. Okay, let's see next one. We'll do one with a cubic in it now, like d. So maybe you want to write d down here. Yeah. Okay, D. Okay. Can you call out D, please? What was it on the top?
48.
Yeah.
Over 512 cubed.
Yeah.
Plus 1088x squared.
Yeah.
Plus 622x.
Yeah. Okay. So of course we need to factorize here, and we'll be dirty, sneaky, cheap and use the calculator because no, you did this in semester 1. Yes, that's it. That's it. Exactly right. Yes. Yeah. The good news is, usually in the exam for this question they give you the factors anyways. So I mean, I suppose technically it's possible that they don't give you the factors because you know how to find the factors, but because this question is already quite long, it will be too long if you have to do this part as well. So this is why I'm not so fussy about cheating here. 54, 5112, 1088, 632 and 63. So we have 8x plus 1 as the first one, 8x plus 7 as the next one, and 8x plus 9 as the last one. Yeah. Okay, so we have a nice situation here. 8x plus 1, 8x plus 7, 8x plus 9, because these are linear, they each have two constants. On the top should be constants with one constant, so just an A, a B, a C. And we use our usual trick of multiplying by the factors. I'm not even going to write them down because you can imagine what they are. They're just the three factors here. So what's nice is this will cancel all of this. The first one cancels the first one, the second one cancels the second one, and the third one cancels the third one. So you're left with 48 equals A, 8x plus 7, 8x plus 9, plus B, 8x plus 1, that's it, 8x plus 9, the middle one was cancelled, and C, 8x plus 1, 8x plus 7. Okay, so what should we choose first for x? Let x equal, so let's say I want to get the A. What could I make the x here? I could make the x equal to minus 1 over 8. Because this would cancel, and this one would cancel, leaving me with only this one. Can you see that? Yeah. So I would get 48 equals, so I'd have, maybe we can do this in our head, because this would be 6 multiplied by, that would be a minus 1, 6 multiplied by 8, 6 multiplied by 8, 48, isn't it? My goodness, let's double check that. Yeah. So that's nice. You get 48 equals 48a, so a equals 1. What could I choose next for x if I want to only get the b? I could choose minus 7 over 8, I think. That will kill this one, and the last one, keep the middle one. So I'd get 48 equals, okay, so minus 7 over 8, that would be minus 7 plus 1, minus 6 times 2, minus 12. 48 equals minus 12b. So then b would equal minus 4. And lastly, what about the c? Yep, that's it, minus 9 over 8. That's gone, that's gone. So minus 9 over 8, that would be minus 8. And then minus 9 plus 7, minus 2, and what did I say this one was? Minus 16. 16c, so c equals 3. So I have my a, b, and c now. Yeah? Let me just double check that answer. Nope. 1, 3 minus 4. Oh no, yeah, 1, 3 minus 4. Yeah, I might have written them in a different order at the back, it doesn't matter. 1, 3 and minus 4 is it. Yeah. Okay. Got that, Mr. Reed? No. Let's have a look. So I kind of want to do H, but I almost feel like I don't need to, because what's interesting about H is that one of the, well, you know what, okay, I will do it, but maybe I won't do all the steps, I'll just do it enough so that you could finish it. So if you want to, I think I'll do H and, maybe I'll do H and, yeah, I'll do H and I, we'll finish on H and I, so if you can write down H, please. Got that? Okay. So what is the story for H then? What do you have on the top?
16x squared
Yep.
plus 65x
Yep.
plus 18
Yep.
over 28x cubed plus 36x squared plus 15x plus 12.
Okay, so we should have three factors here. $28. No, did I pick the wrong mode? 28, 36, 15, 12.
Only 2, not 4.
Is it? Yes.
Sorry.
That's okay. That will make it better, I hope. Right. 28, 36, 15, 2. 7x plus 2. Two x plus 1. And then that's it. What's happened? Why did the calculator only give me 2 when there should be 3? One of them's repeated.
Which?
Excellent question. That's why I wanted to do it. Which one is repeated?
And you have to do it.
Yeah, actually, since it's your question, you have to give us the answer. Which one's repeated? If you think about it, there's a trick here to tell which. Why?
All the numbers are in 28, 10, 15.
That's a good reason, but not a good enough reason. Yeah. I'll tell you how. Here's the trick. This number at the back, the 2, you get that number when the 3 numbers at the back multiply. So, the square, it has to be 2x plus 1, because if it was 7x plus 2, you'd have a 4 at the back. So it's that one that's repeated. Yeah. So here we have 7x plus 2, here we have 2x plus 1, and here we don't have 2x plus 1 because it's repeated, we square it. Now what can I have here? Yep.
Yeah. Well, you can have a linear and find it.
You could have a linear here. But we are free to make one of these 0. Which one?
Yeah.
Might as well. So in other words, we can just do this one as ABC.
Yeah.
Yeah. And you kind of have a feel for what's going to happen. When you multiply by the factors, you'll end up with A times 2x plus 1 squared, because you'll have 2 of these left, plus B, what would it be here? Correct. And then finally, C times 7x plus 2. Anything else? No. Because the 2 of them here cancel with the 2 here. And we won't do it, but just tell me what to choose for x. Let x equal to, minus 2 over 7, and that gives you A. And then let x equal to a half. Now, that gives you B, but please note, what will happen is this one will go, this one will stay, and this one will stay. Oh, I'm sorry, this one will go. So actually this one here doesn't give you B, it gives you C. And finally, what do we left for x at the end? Well, for the last one it actually doesn't matter, because because you know the A and because you know the C, it doesn't matter. You might as well just pick 0, put in the A and the C and the X, and you can get the B then. So you can get ACB if you use these numbers here, and then it's finished. Likewise, you could have gone with CX here, and you'd get different numbers, and that would be fine. So I'll just put dot dot dots here, because you know the rest of the story. Okay, one more example after this. It's not too bad outside. Continue? Oh. Musharif was noticing yesterday I drink 1 coffee per class. Wasn't it? It's necessary. Yeah. Okay, got this? Right, one more. We said I. You can write I down. Alright. What have I got on the top?
6x squared. Plus 45.
And on the bottom?
Minus 3 x cubed. Minus 13x squared. Minus 28 x. Minus 1.
Like this. Like mode 54. Oops. Mode 54. Mode. Okay. Mode 54. Right. Minus 3. Minus 13. Minus 28. Minus 8. 3x plus 1. Dun dun dun. It only gives us one factor.
So, yeah, only x plus 1.
No, it still needs to be cubic, so what's here?
Quadratic.
A quadratic. Not any old quadratic, a quadratic that doesn't have factors. What do you think? The calculator only gave us one factor, but we still need to make the cubic. So there must be a quadratic here that has no factors. Yeah? How can I get this quadratic? Any ideas?
Yeah, long division, yeah.
Long division will give you that missing quadratic. Right, first, minus 1. Yeah? Actually, part of me is tempted just to take the minus out and change all of these to plus. I think I'll just make life easier. So this would be plus x squared. So this would be 3x cubed plus x squared. I subtract and I get 12x squared plus 28x plus 4x, isn't it? 12x squared plus 4x, 24x plus 8. Isn't it?
8. Yeah, so 8.
So it has to finish with 8. Yeah. 24x plus 8. So that's the missing quadratic, x squared plus 4x plus 8. And you can check it doesn't have roots because the discriminant will be 16 minus 32.
Yeah.
So it doesn't have roots. So it means that your cubic is 3x plus 1 times x squared plus 4x plus 8. So this is a bit different. The first one would be a over 3x plus 1. And now, what would the next one be? On the top. I can't make one of them 0. Why not?
Yeah, 2 constants, right? So, 3 constants.
There's 3 constants here, so on the top I should have 2. So I cannot make one of them 0. But it's still done the same way. So you multiply by the 2 factors here, and you would end up with 6x squared plus 15x plus 45 equals a times
X squared.
x squared plus 4x plus 8 plus bx plus c times 3x plus 1. Now, is it possible to easily solve this? For example,
You can make X minus 1 over 3.
yeah, if you make x equal minus 1 over 3, what would that give you, Ms. Sharif?
Gives you A.
Gives a, because this is gone. Yeah. Next, you should make x equal to
Yeah.
0. This is gone. This you know, so that one would give you,
B.
no, gives you what? C.
C.
Yeah. So lastly, it doesn't matter what you pick for the last one, because you know A and C, anything will give you the B. So what's the easy number to pick? 1. And then this will give you B. And then you're finished then. Okay. Right, so you'd want to write this one down. And we still have 3 more lessons on this. It only gets harder.
I guess the second lesson will be integrated.
Nope, not yet.
Really?
Not yet.
Not yet. That's the 3rd lesson of the 4. The next lesson, Ms. Sharif, is what do you do if the top is a higher power than the bottom? Like a cubic over a quadratic. This one's okay, yep. This would be a section A question, whereas the next one's probably more like section B.
Which lesson did we do?
So far? What have we done so far? There's usually a big section B question on functions and mappings.
And further integration? A.
That's kind of mixed with trigonometry usually, which we haven't done yet.
And from B or A?
The further integration could be both.
Is this year the first year where they combine Simpson 1 and Simpson Finance?
Yeah, but I actually think for you,
I finished.
okay, but you don't know if I'm finished.
I said we will do it.
Maybe I was lying. Yeah, I think it's kind of good news, because what would happen in the past, in the old system, you would have semester 1 with a semester 1 exam, and then semester 2 with a semester 2 exam, and this would have only semester 1 in it, and this would have only semester 2 in it. Whereas now, you have a semester 1 exam with semester 1, but then at the end, your final exam is 1 and a 2. Now that's actually good, because if you think about it here, that means 10% of your tests are on semester 1, and this last time was, no, I think it was, no, I'm so sorry. This was previously 30, and this here was previously, in the old system it was, no, I screwed that up. Yeah, 30, and this is a 40. In the new system, this is a 10, and this is a 70. Yes? Now, if you look at the old system, how much of your time was spent on semester 1 material? Only this. So 30% of your grade was given for semester 1. In the new system, it's 10%, and really half of this exam should be from semester 1 material. So that's 35% and this here is 10%. So if you add these together, you get 45%. So in other words, more of your grade is coming from knowledge of semester 1 than knowledge of semester 2. So I actually think this change, although I know it seems like you have to do more for the final exam, in total I think it's a benefit to you because more of your grade comes from simpler material. True, you have to remember more for the end of the year, but more of it comes from simpler material. So I think it's an advantage. Because students in engineering did really badly in this exam because it was only semester 2, it was a really hard exam, whereas for you, half of it should be familiar from semester 1. And anyway, everything in semester 1 is continued in semester 2 anyway, so the only things you have to relearn are the stuff we don't do in semester 2. And there's only one topic that you do in semester 1 that you don't do in semester 2, sequence and series, which wasn't particularly big or hard, the AP and the GP sequences. Yeah. So I think it's a good thing for you. We'll see next summer if you feel that way after the exam, but I still think it's a good thing here. And then